Let me begin with a word of prayer once I get up here. All right. I'll start. Heavenly Father, we thank you for this day again. I thank you for these students, this class. Just pray that you guide our steps today. Help us to glorify you in what we do. And just the students would ask good questions as they think of them, Lord. In your name I pray, Lord Jesus. Amen.
Amen.
So do you guys have any questions about anything? Yes, Michael.
What is today's notes going to be based on?
Well, that depends on what questions you guys ask. But roughly speaking, we're following the course planner. I might get a little bit ahead. I might do some radical things today. We'll see.
This?
Yeah, that.
Oh, so 1.7.
Let's see, what is...
According to this, rational equations and inequalities.
Well, we have done rational equations and inequalities. We might do another. I'll probably do another example of those too. Are there any questions about anything in particular, though, anybody? No? Okay. So here, let me take a swing at one of these here.
Oh, 3.5.
I suppose it is. Example 1. Suppose we're up against x minus 3 times x minus 4 times x minus 5 squared divided by x squared minus 1 less than or equal to 0. How would we solve this inequality, guys? What should we do? Yes, Michael?
Factor first.
Factor first is a good idea. Yep. So let's see here. So what we're going to do is we're going to factor that. Now the numerator is already factored, right? So there's nothing to do up there. But downstairs we've got x plus 1 times x minus 1, right? Okay, so now it's completely factored, and we can draw our number line. What are my critical numbers? Looks like I got minus 1.
Negative 1.
Mm-hmm. 1, 3, 4, and last but not least 5. Bless you. So we need to figure out where is it positive, where is it negative, right? So we should plug a number in perhaps. I like to plug in a big number because it's easy to think about. Like if I plug in, I don't know, 10 or something, you can easily see that everything there is positive, right? Like x minus 10 minus 3, 10 minus 4, 10 minus 5, 10 plus 1, 10 minus 1. These are all positive numbers, right? So if I take the quotient of those, I still get a positive number, right? So that shows me that I start out positive here, right? Now, we got to be careful. This is a square, right? So that means that I don't flip signs. I stay positive as I go across that, all right? Now I get to 4, I flip signs. I get to 3, I flip the sign again. I get to 1, I flip the sign again. I get to minus 1, I flip the sign again. See, because the only factor here, which is has an even multiplicity, is the x minus 5 factor. So then what? Yes, Michael?
Oh, now we need to find the terms that go into less than or equal to 0.
Right, so we're looking for the negatives, right?
Negative 1, 1, 3, 3, 4.
All right, and then the question is, those numbers, negative 1, 1, and 3, 4, which one of those do we include? Which one of those do we exclude? We allow equals to 0, right? So if it's making the numerator 0, we want to keep it. Let's see here. So, but if it makes the denominator 0, we need to get rid of it. So 1 and minus 1, those are both bad news. Those get division by 0. So we exclude both of these guys. How about 3? 3 makes the numerator 0. That's fine. We can include that. And 4 also makes the numerator 0. We can include that. Is there anything I'm missing? To be picky. We're solving less than or equal to 0, right? So included in the solution set should be the numbers 3, 4, and 5. I've got 3 and 4, but I'm missing 5. So the way to include 5 is just say union with the set which just contains 5. And there you go. That's the solution set to this inequality. Yes, sir?
Why is 5 included if we're looking at negatives specifically for less than?
It's less than or equal to 0, though. So that makes it equal to 0, so it gets included. Yes, Michael?
So why is 5 included in the answer?
Because that makes the fraction 0. If I plug 5 in, I get 0. 0 equals 0, so it's true.
So the numerator.
So, yep, the numerator. That's right.
But, oh.
Aha! There we go. Let's see here. So, example 2. Let's see if I can find us a good one. All right, so something like x over x squared plus x. Let me make that a plus 2x. All right, less than 1 over x plus 2. Yes?
Sorry, going back to number 1, can you again why you need 5?
Sure. The 5 is there because we're solving less than or equal to 0. So does 5, when you plug 5 into this, does it make it 0? Right here, right? It does. So if the numerator is 0, that makes the fraction 0. Therefore, this is part of the solution. And I have to write it that way because 5 is isolated. Nothing else over here works. Everything else makes the expression positive. It's just that 5 on its lonesome over there. Yep.
The only instance where it's bracketed is in case of the numerator setting it equal to that number, right? It's like
Right.
the denominator doesn't matter.
Denominator does not give us, well, we can't have the denominator equal to 0.
That makes sense.
Does it matter? Well, that's a loaded question. I don't know. I think it matters. It matters because those are places where it can change from positive to negative. It matters because those are places that we're going to have vertical asymptotes in our graph when we start graphing these things. Okay, so next up here, this isn't in the right format, right? How do I fix this? What do I want to do?
Factor it.
Factor it? That's
To the left side.
you want to put everything on the left side. Okay, yeah. Yeah, left side.
Left side. Oh.
You're fine, Michael. X times x plus 2 minus, you had the right idea, Michael. I was thinking left and right are flipped, so my bad. There you go. That's what you wanted me to do, right?
I was expecting. Oh, that's what I did for the left side.
Uh-oh. What happened here? Huh. Well, this is actually kind of interesting, isn't it? What happens here? If x is not equal to 0, right? Then we may cancel x over x, right? And what does this become? This becomes what? 1 over x plus 2 minus 1 over x plus 2 less than 0, which gives me what? That gives me 0 less than 0.
Oh no, impossible.
Can 0 be less than 0?
No.
Unfortunately not.
So what's the solution to this?
No solution.
That's right, no solution. And how about the one place where the algebra didn't happen, x equal to 0? Is that even allowed? Can we have x equal to 0 in this problem? No, that's outside the domain of the expression. So sorry, this example is kind of like anticlimactic. The answer is no solution. If you wanted to talk about the solution set here, it would be the empty set. All right. So again, any questions about this material? Okay, yep.
Can we do a better example of like converting it to the most simplified form that way?
You wanna talk about simplified forms again? Going
Like
back.
that one obviously was just
You wanna-
about to the x over x cancel.
You want to go back to simplified forms, huh?
Sure, that'd be cool.
All right, we could do that. Give me a second here. Let's see here. Now, how about this? 3 plus 1 over x minus 2 equals to x. So this is actually not, I mean, I didn't quite listen to your instruction. I've decided to take us back to a rational equation again. Wouldn't hurt to do another one of these, right? So this is an equation, it's not an inequality, so what's the answer going to, do we do the number line thing here? No, right? Our goal is to just what?
Find
Yeah,
the least common denominator.
Fi-
Oh. I'm getting a call.
Okay. So here, we want to solve for x, right? So the first thing you want to do is get rid of the fractions, right? How can we clear the fraction out? What do we do?
Oh, find the least common multiple.
Right? Well, there's only one denominator here, so we just multiply by it, right?
X
So,
minus 2.
right, multiply by x minus 2. And that will give us 3 times x minus 2 plus 1 is equal to x times x minus 2. See, because the x minus 2 cancels on the 1 over x term, x minus 2 term. Are we all got it? Now what? Now we probably should do what? Like distribute, collect? Yes, sir. Excuse me, not sir. I default to sir, you know. So anyway, what were you saying? Cross multiplied. Yeah, if you, well, that would have been an alternative approach. Like you could have, instead of doing that, I could have done 1 over x minus 2 is x minus 3, like that. And then I could have cross multiplied, sure. That would have been another way to do it. Sure. But we should all get to the same point down here, which is what? 3x minus 6 plus 1 is equal to x squared minus 2x. And if we bring everything to the side where x squared is positive, we have x squared minus 5x plus 5, I think. Are we good?
Nope. We still have to factor.
Oh, yeah, I don't know about this one. I think I'm going to complete the square.
Oh, complete the square.
Yeah, complete the square. So x minus 5 halves squared minus 25 over 4 plus 5. Now 5 over 4 is how many?
Can you move out? I can't.
20 over 4 equal to 0. Let's see. So it looks like it does factor, right? That's good. It looks like we're going to have solutions. So we're not interested in factoring, we're really just trying to solve for x, right? So let's isolate the square. And when we isolate the square, we get what? I think we get 5/4 on the other side. Right? Now,
Wait, why isn't this negative?
because I moved it to the other side. So
Oh,
Yeah.
plus 25 over 4 minus 20 over 4.
Very good, yes. So this gives us then x minus 5/2 is equal to plus or minus the square root of 5 over 4, which we could rewrite as x equals to 5 plus or minus the square root of 5, all divided by 2. So this problem has two answers. All right? Now, with any of these, we have to check ourselves and make sure that that doesn't give you something undefined back in the original problem, does it? What's the trouble spot for the original problem? It's just x equals to 2. These are not 2, right? There's no way that number is 2. It's whatever it is. It's something ugly, but excuse me, this isn't ugly. I shouldn't speak ill of this. This is a beautiful number. It's got a 5. It's got a square root of 5. Division by 2. It's nice. It's not so bad, right? You guys looking kind of ambivalent. I feel like you harbor some animus against this number in your heart. You shouldn't live like that. That bitterness is going to eat you up inside. You need to forgive the numbers. No? You can't forgive the numbers? Well, then the numbers won't forgive you.
Well, that sounds good.
So let me get this straight.
Yes.
When you say simplify in the missions homework, do you need to do it like this?
Oh, well, simplifying the missions homework. Give me one. I'll do it for you. For example, which one? Oh, fine. I'll make it up then.
Okay.
So x times x squared minus 1 squared divided by x squared plus 2x plus 1. All right. Oh, I don't know. Times x squared minus 4. And for good measure, I'll throw an x plus 2 up here. All right, there we go. Something like that is what you're talking about, right? So in the mission, I ask you to simplify some fractions, right? So what do you want to do there? If it's just one fraction already, you want to factor everything, right? And then cancel out like terms. If it's a sum of things, you want to make a common denominator and try to like combine things, right? So it kind of depends on the problem. This one,
Oh, I got another call.
if you need to take it, you can go take it, Michael. It's
Oh,
fine.
but I wouldn't want to miss any of the session.
Okay, well then don't take it. Let's see here. So, so we have x plus 1 times x minus 1, right? But they're squared. So we have x. You guys see this? Do you understand what I did upstairs? So this x squared minus 1 factors to x plus 1 times x minus 1. And I see I have gotten carried away, and I never moved my camera. It's okay, though. I haven't erased anything. That's the main thing, you know. But forget the camera? That's what I did. I forgot the camera. Let's see here. Okay, so do you guys understand that step at the top? Because if x squared minus 1 factors to x plus 1 times x minus 1, and we square it, right, then the square is the factors.
That makes sense.
Right, this, basically this 2 here is what's making me put that 2 there and that 2 there as well.
Yeah, that makes sense.
Now how does x squared plus 2x plus 1 factor? This is what? That is exactly x plus 1 squared. And x squared minus 4 is x plus 2 times x minus 2. So I think we get some nice simplifications here. Do you see it?
So we need to cross out the like terms out.
That's right. So we've got this like of x plus 2 and x plus 2. We've got the x plus 1 squared, and it's upstairs and downstairs. And what are we left with? Well, we're just left with
X times 1 squared over x minus 2.
There you go. And that would be how we'd simplify that. Now, did you find one in the mission that wasn't this pattern that you want me to talk about? No? No?
Oh.
Michael's got one.
Excuse me.
Well, I have one.
So,
We'll come back. Yeah, Michael?
on problem number 75, I have parentheses 5 minus 3x squared
Uh-huh.
over 2x minus 5 parentheses cubed is greater than 0.
That?
I was like, it's not a mission.
That problem?
Yes.
This is from the recommended homework, I'm guessing.
Oh, but it could be useful to me.
Well, yeah, we could do this problem. That's fine. This is a good problem. It's kind of ugly in a sense because it's not like the usual. I have a lot of problems where we've had formatted x plus a number, x minus a number, right? This one pretty much is already factored. We should just deal with these factors as they are. So 5 minus 3x equals to 0 gives us what?
Oh.
X equals to, well, it gives us what? 3x is equal to 5. So x is equal to 5/3. That's one of my critical numbers because this what? This makes numerator 0, right? And how about 2x minus 5 equals 2x minus 5 equals to 0? Well, that gives me 2x is equal to 5, which tells me that x equals to 5/2 is trouble. This makes denominator 0, right? Those are my critical numbers. So I take my number line. Which one comes first, 5/2 or 5/3? Which comes first, 2 or 3?
2, right?
2. So that means 5/3 comes first. See, I'm messing with you guys,
Say like,
right? Well, you're dividing. You're dividing by 2 and 3, right? So a half is bigger than a third, right? And then you just got to plug in some points. What point you want to plug in?
makes denominator 0.
Sorry, I forgot to tell you guys, bring your binoculars. And or your de-glaring machine. There does always get to be some glare at certain angles. If we put in 0, what happens? Where are we? 0 will be over here, right? Plug in 0, I get 5 squared divided by minus 5 cubed. Minus 5 cubed is negative, so we've got a positive over a negative. That means we're going to have minus is here. Now, how about the...
Professor Cook?
Uh-huh.
So 2 is negative 5. Is negative 5 cubed still negative?
Yeah, and minus 5 cubed is equal to minus 125. So it's negative. Yeah. So the critical number 5/3 is coming from which factor? It's coming from the denominator factor. The multiplicity of that is 3. That's odd. That means we flip signs. So we go pluses. All right? Now, how about 5/2? Well, that's coming from the numerator. It's got a multiplicity of 2. So that means we keep the...
I think you said that backwards. Wasn't 5 over 2 from the denominator and 5 over 3 from the numerator?
Did I say it backwards? Sorry. Wait a minute. No, numerator is 5/3. Denominator is 5/2. Did I just say it words backwards?
Yeah, I think you just said
I'm sorry. But I have what's correct here, right?
Yeah.
All right. Sorry.
So if there's a coefficient on top, then keep it positive. the square cube.
Well, whether the sign's positive or negative depends on, we plug in a point. In this case, we plugged in 0, right?
Yes.
And then we're using the sign flip theorem, namely that because 5/3 is coming from this 5 minus 3x squared term. Wait a minute. Oh, my bad. No, this matters. Look, I've flipped things in my mind. 5/3 is coming from which one?
The numerator.
The numerator, which has a power 2. Oopsie. It stayed minus. Dang it indeed, Michael. Let's see here. 5/2, on the other hand, is coming from the numerator, which has the multiplicity 3, so it flips.
Yeah.
All right, there we go. What's the solution?
Five over 2 infinity.
5 over 2 to infinity. Yep, and then 5/2 is not included, right? Because we're solving strictly greater than. So, and anyway, 5/2 makes the denominator 0. That's trouble anyway. We don't have that in our solution. Period. So there you go. All right, let me work a problem that always gives you guys a lot of trouble when I put it on a test, but it really shouldn't, but it does. So let me work this problem here for you guys. I think I have problems like this in the mission. If I don't, I should. So let me make one up for us. Example 6. Suppose you have the square root of xy cubed times x squared y to the minus 1 power divided by the cube root of x times, let's say, y to the power 4. And you're given that that's equal to x to the a, y to the b. And the instructions are find a and b. So how do you solve this kind of problem? Like what is the thought process here? You want to do what? You want to use the laws of exponents to simplify it and force it to be the format which you're looking to get to, right? So we want to take this apart piece by piece and try to understand how to simplify. All right, so let me tell you some rules.
What section is this based on?
It's not, Michael. So this here, it's a combination of several sections. It's probably I would say maybe it fits in section 1.6 for me, maybe.
The second part.
I mean, it's a little bit 1.6. It's a little bit like wherever we first had like laws of exponents.
Combination of ideas.
Yeah. Let me explain how to work it. So, look, one of the things we need to know about is if we have the square root of stuff, all right, then that means
A.
stuff to the 1/2 power. All right. So, this marker's junk. Oh well. Oh, wait, assist. Yes. All right. So one of the things we have is like the square root of a times b is equal to the square root of a times the square root of b. That's one of the properties we have of like square root. Okay. What else can I tell you? If you have a times b to the power s, then that's a to the s, b to the s. All right. The other rules we talked about the other day is like if I have x to the a over y to the b, let's say, that's, oh my bad, I meant to put x to the b down there. That's x to the a minus b. Right? So these are some rules of exponents that we want to use here. All right, so hopefully I've said enough. Let's get to work on what we got here. So my starting thing I'm going to do is just to use that's really the square root of x times the square root of y cubed. All right. And then I have x squared to the minus 1 times y to the minus 1 divided by the cube root of x. Now I need to explain that. Actually, I see now I'm missing a couple rules for you guys. Okay, so another thing. If we have like the mth root of whatever, let's say a, that's a to the 1 over m. And then one other thing, a to the s raised to the t power is a to the st. Now, all of these rules I'm writing, they're only true if a and b are both positive. Like, these are laws of exponents for positive quantities. So whenever I give you a problem like this, it's assumed that x and y are positive, okay? Otherwise, the problem doesn't quite make sense. All right, so let me kind of simplify this a bit. This is really x to the 1/2, all right? This is y to the y cubed to the 1/2. This right here would be x to the minus 2, and then we've got y to the minus 1 divided by what? Well, this is x to the 1/3, and we've got y to the power 4.
That makes a lot more sense.
Now I can bring things together. Bring all my x's together, bring all my y's together. So let me just do it here. We've got x to the what? I've got a 1/2 minus a 2, and then because this is downstairs, minus a 1/3. All right? And then y to the what power? Well, notice this. Yes, Michael?
Y 3 to cube,
Y to the 3/2 from this,
y to the
then minus 1,
halves minus 1,
and then
plus 4.
not plus 4 because
Minus
it's downstairs, so minus 4, yeah. And then we just need to do the arithmetic here, right? So get out your handy dandy calculator and do the arithmetic. Or if you don't have a calculator like me, I guess you have to think. Oh, thinking. Everything is sixths, I guess. 3 minus 12 is minus 9. Did we get minus 11/6? I need some verification. What'd you guys get for this?
Negative 11 over 6, and y equals negative 7 over 2.
Minus 7 over 2 over here?
Yes.
All right. So, now, the thing is, it doesn't matter what order of steps you did these things in. Like, if you did it a different way, you'd still get this as your end product as long as you put x and y like this, right? Now, what's another way I could write this? I could also write this as what? Like 1 over x to the 11/6 times y to the 7/2. So you might have some problems. I'll get out of the way here in a second, Michael. If you wanted to write your answer using positive exponents, that's what it would look like, right? This is the, simplified to expression with positive exponents. All right. But anyway, that wasn't the question, right? What was the question? Find a and b. So what do we have to do? We have to say, look at this. This is like x to the a, y to the b, right? So you just look at it. What's a equal to? What's b equal to? Negative 11/6. And b is what? Minus 7/2. There you go. It's as simple as that. I mean, this one's not that simple. There's kind of a lot of moving pieces in this one, right? But I typically ask a question like this somewhere to test your laws of exponents, right? If you can work this problem carefully, then you understand laws of exponents pretty deeply. Any questions?
Is a problem like this going to be on the mission, Professor Cook?
I think there's a problem like this on the mission somewhere, but Oh, problem 42 is like this? Okay.
All right.
There you go, Michael. All right.
Did the camera get that?
Did the camera get that? That's a mighty fine question. All right, so we are moving on, guys. With the time that remains, I'm going to talk about so-called radical equations. So what's a radical equation? It's what? One that never hesitates, you say?
Never ends.
Oh, it never ends. Huh. Interesting. So this is going to be really shocking. Radical equations are equations that, wait for it, involve, guess what?
Radicals.
Radicals. Okay, there we go. That was kind of a little anticlimactic, wasn't it? But what is a radical? See, yep.
It's like the square root.
It's like the square root. That's pretty much true. So here's the deal. The square root of, well, let me just put it down like this way. The square root of a is equal to b. What's that mean? That means that b squared is equal to a and b is greater than or equal to 0. So it means that if you I mean the square root is by definition non-negative, all right? So when I solve this, what are the solutions to this? Plus or minus the square root of a are the solutions, right? So it's not enough to say that b squared equals to a defines the square root. That's part of the story, but we do insist on it being the positive root, all right? And the same is true for like any even root. So if we have like an even root, 2n would be even. 2n to the a is equal to b. That means that b to the 2n power is equal to a, and that, b is greater than or equal to 0. All right? So even roots are by assumption non-negative. Something interesting happens. Odd roots don't suffer this. Like odd roots, if I have the odd root, like 2n plus 1 is an odd number, that equals to b if and only if like b to the 2n plus 1 is equal to a. Just that. So like odd roots, you can take the odd root of a negative number, it's just equal to a negative number. There's no issue. There's a unique, let me just be more explicit here. So like, where was I? Example 7. So for example, if I take the fourth root of 16, what is it equal to? Well, it's equal to, you could get your calculator out and figure this out, right? You can do, if you want to in your calculator, you can put 16 to the 1/4 power, right? Or if you want to, you do 16 to the 0.25 power, and what you'll get is 2. Because 2 times 2 times 2 times 2 is 4 times 4, which is 16. So the fourth root of 16 is 2.
Interesting.
It is nevertheless true that if I'm solving, right, x to the 4th equals to 16, that implies, in fact, that x is equal to plus or minus 2. So the equation x to the 4th equals to 16 actually has 2 solutions. But one of those solutions we define to be the fourth root. The other one we don't. Now, on the other hand, if I talk about the cube root of minus 8, Well, the answer is minus 2. Why is that? Well, minus 2 cubed is minus 2 times minus 2 times minus 2, which is, well, minus 8.
Give 8.
Right. And if we solve, see the reason that there was x plus or minus 2 up there, if you want to get into it, is because this factors to x4 minus 16, which is x squared plus 4 times x minus 2 times x plus 2 equals to 0, you see? And so there were just two solutions there, 2 and minus 2. Those are the two solutions. How does the problem x cubed equals to minus 8 work out? Well, this is x cubed plus 8 equals to 0, which is x plus 2, see, times x squared minus 2x plus 4, actually. And we have discussed before that if you put this equal to 0, the quadratic here is irreducible. It gives you no solutions. Well, there are two solutions, but they're complex, so they're dead to us in the current discussion because we don't allow complex numbers in this larger discussion here. So the only solution is exactly x equals to minus 2, right? That's the unique cube root of a negative number. So the cube root of any real number, it's a real number. Yay. Square roots are the picky ones, because if we take the square root of a negative number, if we're going to deal with like quadratic formula, that gives us a complex number, right? But here, if we take the square root of a negative number, in this context, we're usually just going to be like, we're not doing that. I mean, we assume that we're working with positive quantities in this discussion to keep it simpler, all right? Any questions? Yeah.
How did you get negative 2 right there?
Oh, if this times that is 0, either this has to be 0, which is impossible for any real number, or that has to be 0, which is true for x equal to minus 2.
So plug in the negative 2, and that's the answer in the middle.
Yeah. But as I showed you up here, minus 2 is a cube root of 8, right? Because if you multiply it by itself 3 times, you get back to minus 8, right? Listen, you don't have to take my word for it. You have a calculator. You can put in minus 8 to the 1/3 power. It should give you minus 2. Okay? So now here's where it gets fussy. Here's where it gets a little bit fussy. Let me just get this out of my system while we're at it. So check this out. If we take the square root of a squared, we actually get the absolute value of a. But if I take the cube root of a cubed, I get what? I just get a again, actually. So there's a difference between the cube root and the square root. Like the square root of the square gives you the absolute value back. Because the square root is by definition non-negative, it has to give us back absolute value. There's an asymmetry here, right? Like if I do the square root of a, all of that squared, well, guess what? That's equal to a again. And the cube root of a cubed, well, that's also equal to a again. So there's something a little funny that happens with the square root. All right. Now, we'll come back to this probably when I talk about inverse functions in about a week or so. Whatever we talk about. I can't remember when we talk about it. Maybe a couple weeks. But when we talk about it, we'll talk about it. Let's say that. All right. There is your brief introduction to radicals. Let's solve a radical equation. After all, I haven't solved an equation yet, really. So how would you solve a radical equation, do you think? Yes, Michael?
First, you need to isolate the radical.
Isolate the radical is a good idea. My apologies if you didn't write that down yet. I'm sorry. I seem to have erased something I just wrote. So sorry. Example 8. So suppose we're solving the square root of 3x plus 1 equals 2x. How would you solve this equation? And I'll make an even easier one here. Example 9 rather.
Isolate the radical on one.
what if we're solving x to like the 3/2 power equals to 100? See if we can solve that. All right. So, Michael, the radical's already isolated in example 8, right?
The radical is already isolated.
So how do we kill the square root? We
Square it.
square it, right. So we square both sides. And that gives us 3x plus 1 equals to x squared, which is unfortunate. Permission to change this +1 to a -2.
Sure.
Thank you.
Oh, right.
Thank you.
Right. Convert it into standard form.
Okay, yes, Michael, let's do that. X squared minus 3x plus 2 equals to 0. Now it factors. And so the solutions are potentially x equals to 1 and x equals to 2. Now, are they actually solutions?
No, but they're proposed.
So
we need to check our answers.
right? So if we try the square root of 3 times 1 minus 2, and if we try the square root of 3 times 2 minus 2, what do we get? We get square root of 1, right? Or we get the square root of 4, so we get 2, or we get 1, right? And so here we've got x equals to 1. Here we've got x equals to 2. Well, you know what? I think we got a winner. So yeah, they both solve the equation, the square root of 3x minus 2 equals to x. I'm kind of surprised. Okay. How do you solve the other one? All right, you'd be like, you don't have enough time to do 2 problems? What are you doing, you idiot?
Where is example?
Right?
Oh,
Like, you dummy? How dare you do another example? We got to go. Look, this is very,
no, we have time.
this is very, very simple. The natural enemy, the natural enemy of 3/2 with respect to multiplication is 2/3. So you simply take this to the 2/3 power. You take that to the 2/3 power. These annihilate, and 2/3 times 3/2 is 1, so that's just x to the 1 equals 100 to the 2/3 power, and the answer is x equals to 100 to the 2/3 power, and that's the answer. Of course, you could plug that in your calculator and give me a number if you wanted to, but I don't have my calculator, so that's as far as we're going to get today. We will, of course, do more of these next time. Just trying to get us started.
Excuse me,